So now, the integrated information theory of consciousness, which we are trying to present very briefly today, is something that was developed over the years to try to address the problem, the hard problem, from the right side, that is, from phenomenology itself. And the way to do that is to describe some axioms of consciousness, that is, some essential properties that every single experience you have must satisfy. And here are the axioms we currently think are crucial. And they are illustrated using a drawing colorized here by a physicist and phenomenologist, Ernst Mach, who shows his intrinsic perspective, so to speak, looking at himself from one eye only. And the idea is then that, as Descartes said and Christof reminded us of, experience exists, you exist, you're having an experience. That's an undeniable fact, in fact the most undeniable fact of all, and everything else is inference. That's the first axiom. Another axiom, which is pretty obvious, is that it is structured. Every experience has aspects to it, different aspects, right and left, top and bottom, hands, books, things, colors, all kinds of things inside any experience, including pure darkness. A key aspect that has been ignored even by philosophers, which is quite remarkable, is information from the intrinsic perspective here. Experience is differentiated. It means that every experience is what it is that particular thing. The one you're having now is a unique kind of experience that you didn't have before, presumably, and it is what it is by differing in its own particular way from who knows how many other experiences that you could possibly have. So it's that particular one in that particular way. Then there is integration. So this has been remarked by people like Kant. Every experience cannot be subdivided into independent components. When you have an experience, it's one. Yes, you can describe the left side and the right side. You can say, I see shapes and I see colors. I hear sound and I understand meanings, but you cannot decouple them. You cannot divide yourself into two parts. One sees the left and one sees the right. One sees the shapes and one sees the color independently. That's simply impossible. Experience is always one. And finally, exclusion. Experience is unique. When you have an experience, there is only one of those. There is no superposition. And what I want to briefly indicate there is that, say, the experience you're having now, let's say, is in color. There is not simultaneously another you who is experiencing the same thing without the color, and another one without seeing faces, and another one without hearing sounds, and another one only the left side, and so on. A multitude of experiences that are defective in one little part. Nor, for that matter, is there a larger experience that includes what you're having plus the value of your blood pressure or what's going on in your gut. So it's always just one. It also flows at a particular spatiotemporal scale. So right now, experience sort of goes, we think, 1 per 100 milliseconds or so, plus or minus something. And there are plenty of experiments indicating that that is the case. There is not simultaneously a number of other U's that are experiencing things much faster every microsecond or much slower, one that can integrate an entire experience across the entire day, say, that you experienced the entire day you had, and so on. It's only one. Now, the whole idea here is to say, if these are the essential properties of every experience, and that definitely exists, we all think there is an outside physical world. How does that physical world have to be structured in order to account for these essential properties? And so here the idea is to get this parallel postulate about the nature of the physical world that can support experience, that go from, say, the existence, so experience exists, then there must be something out there, which we all believe, and that something out there must have certain properties. Well, it first of all should exist too, what supports consciousness, and one way to consider existence, as I briefly mentioned the other day, is that you must make a difference to yourself. So there must be something that has, let's call it causal power. It must be such that it can be affected and can have effects. If it doesn't have a possibility to be affected or have effects, it might as well not exist. So we think there are mechanisms out there in a state, for instance, neurons in a brain that are on or off, and they somehow can have causes and effects. If you have a system that has only things that cause it, well, those things are outside the system, like a TMS, a way of, as I will show you, stimulating the brain from the outside that receives no feedback from the brain. That's not really part of the system. We don't experience it indeed. And for the same reason, if you have an fMRI recording all the activity of your brain, even all your neurons, if one day that were possible, but there is no feedback, that would be just a copy of your brain. It would not be part of it because it has no way to affect it on the other way around. Now, composition, experience is structured, translates here, very briefly, into, well, whatever these mechanisms are that form a system with causes and effects that can generate your experience, they can be structured. And here we see the power set of these simple three elements I'm going to show repeatedly, in which, some on and some off. You can consider individual elements, so the first order elementary mechanism. Then you have the power set of the combination of 2, 3, 4, and so on. So that's the possible substrate for this being structured of experience. Here is information. Remember, it's one out of many. It's that particular one done in that particular way. And here, as I showed you the other day, is a brief introduction to the notion then that if you have an isolated, in this case, system made of three elements in a state, for instance, the OR gate here is on and the other two gates are off, but think of them as neurons that fire or don't, at least I think of them that way. Well, by the mere fact of being those mechanisms and being in that state, they will have an intrinsic property, which is that of constraining the past and the future of the system. And those probability distributions, the cause repertoire and the effect repertoires, you can calculate. It is basically, if I am, for instance, if you take A, an OR gate, and I am on at the very bottom, then I'm going to constrain the past of the system in a certain way, and I'm going to constrain the future in a certain way. I don't need to do anything. It's just because I am an OR gate and I am on. And this is true combinatorially for all subsets of the system. So information is how you, from the intrinsic perspective, constrain the past and the future. Integration, well, that had not really been addressed in any way, but it's rather an important concept because, as you can see here, we take again that ABC system, that is the information it sort of generates, meaning specifying past and future, but is it a system? As I mentioned the other day, if you are reducible to parts, as a whole you don't exist. There is no reason to invoke an additional existence of the whole above and beyond the parts, and the parts do all the job there is to be done. So here we can test that by cutting a system, literally cutting it with partitions, and finding the minimum partition, the one that is cutting the system in the most effective parts. That is, we ask how much can the parts do for any partition. Once you find that minimum partition, which is indicated there for that system, it's the partition between A, B, and C at the bottom, you see what happens to the information the system generates. Basically, what are the cause-effect repertoires that are left after you do the cut. And then you can measure a distance between the distribution of cause-effect repertoires before the cut and after the cut. That's how much of a difference it made to make that cut to the system. And if we go for the minimum partition, we know that that system is at least that much, that distance above its part. It does something as a system. We can quantify that with a quantity called phi, which stands for integrated information. This is essentially capturing the notion to what extent is a system physically irreducible in terms of the information it specifies. Now, this is true for the system as a whole. How much is the set of cause-effect repertoires reducible? It's also true, we think, for the individual sub-mechanisms. That is, each element specifies its own past and future. Is that mechanism reducible? If two elements together don't do anything above and beyond the parts, then they don't do anything within the system. And finally, exclusion. As I remind you, there is only one experience, and at a particular spatial-temporal scale. But let's just look at space here. So again, we have system ABC now embedded in an outside world with inputs from E, for instance, and output to D. Now, there is no particular reason why we should have chosen system ABC as our system, the one that eventually might be conscious. We could have chosen AB only, BC only, AC only, or the entire system of 5 elements. So the idea here is that what you want to look for is a maximum of integrated information. In other words, you want to ask, what are the set of causes and effects that do the best job in explaining what the system does to itself, and you choose that and only that. Anything else doesn't exist because its job has already been done, so to speak. And if you do this systematically for every subset, you'll find that ABC has the maximum of integrated information. Anything smaller than that or anything bigger than that is less. And so we say that ABC is the unique thing that generates your experience. We apply the same logic to the sub-mechanism within the system. So A, for instance, could have several kinds of cause-effect repertoires, but we cannot accept the idea that you can multiply causes, that you can have many things causing the same effect. So there is only one cause, and that is the most irreducible cause. There's a lot more to be said about that, but at least that's the idea. And finally, this brings us then to the notion that once we do all of this crazy combinatorial work, which takes a long time to do even in the computer, you find that, say, that system ABC in that particular state is a maximally irreducible entity in terms of causes and effects onto itself. That is the set of cause-effect repertoires specified which are irreducible, and it is called a maximally irreducible conceptual structure. And the system itself is called a complex, the one that generates a maximally irreducible conceptual structure. We shorten it into a Qualia. And the right side just plots those cause-effect repertoires, those distributions, into a space that we call Qualia space, where each axis is a possible state of the system in the past and in the future, and each star is one of these irreducible cause-effect repertoires, which we call concepts. And the size of the star is how irreducible the concept is measured by the value of small phi max, 0.5 in this case, from one particular star. It says, if this, then that, essentially within that system. And big phi, 1.92, is how irreducible the entire conceptual structure is. So in general, for any system, we could do this analysis, and we could come up with what it says about itself and how much it says about itself. And the key identity that integrated information theory proposes is that an experience is a maximally integrated conceptual structure. And it has a certain value of phi max, big phi max. That's how much it feels like to be that. That is the amount or quantity of consciousness. And it has a particular shape, if you wish, in Qualia space, the set of its irreducible concepts, which is what it feels like. So both the quantity and the quality of consciousness are in principle accounted for, and according to the theory, this is indeed an identity. There is nothing more or less. It is like to be that particular system in that state. So let me now show you just a few examples that follow from the theory, some corollaries, just a few, and then I'll give you a couple of predictions. So if you assume then that that is the case, in general, one corollary will be that any system will break down into complexes of larger or smaller size. For instance, this bigger system here boils down into ABC, the one we saw before, which is a complex that specifies a maximally irreducible conceptual structure, which will be conscious in that particular way. But there are also other small complexes which are completely isolated from it, even if there are interactions among them. So everything condenses down into loci, like my consciousness, your consciousness, his consciousness. Even if we talk, we are all separated, as we know to be the case, and we can measure it in principle. It also shows the influence of architecture. Here you have a sort of modular architecture in A, where you have a set of elements which are interconnected, but in a certain way. It turns out this breaks down into individual little consciousnesses, very, very minimal ones with two concepts each, but there is no larger entity at all. So you don't have one big consciousness, you have a lot of small ones. In the middle you have another interesting system, 5 elements, all-to-all connectivity, majority rule, if more than 3 fire, I fire. And in that case, the system is one complex, it forms one entity, but it has only 5 concepts, and they're all elementary concepts, the ones specified by each individual element. And by the way, they're all the same. So there's only one star, if you wish, in the past and in the future. It's a totally trivial system with a minimum value of big phi. So it's minimally conscious, only conscious of one little thing, this and not this. On the right is a system with 5 elements, same logic, but only 3 connections per element, and they are different from each individual element. So we have introduced some differentiation. It's not homogeneous like before. Now suddenly it is still one entity, so it's a complex, but big phi is much higher, it's 10.75, and it has 30 different concepts of elementary and higher order. So now it is like something to be that system, and it's something more interesting than before. It breaks many symmetries. So we assume this is sort of true for many systems if you could analyze them properly. Another obvious consequence is that the consciousness can be graded. You can see here by changing the strength of the connections, which can happen in our brain, from high to medium to very low, you can have one entity with high consciousness, so to speak, another one with much less so, but still one entity, and then it breaks down into sub-entities. We think that happens when you go into sleep, as I'll show you. Another counterintuitive consequence is that a system made of inactive elements that supposedly do nothing, okay, these are copy gates that just do nothing at all, they are all off. This could be neurons that are off, will still generate consciousness of a certain kind. So you don't need to pass messages around or signal. It's an intrinsic property of something that is and has that ability of constraining the past and the future. Another consequence, you can have a very simple system, like a photodiode with memory there, which can actually generate a minimum amount of consciousness. That's actually the smallest amount. We call it really minimally conscious. It is like something to be that photodiode, although it's so trivially low that it doesn't even make much of a difference to talk about it, but it is a minimal distinction. It's this rather than not this. It doesn't matter whether you have a photodiode, a blue detector, or a thermistor. In that case, intrinsically, it just feels like just a little bit and nothing more. An interesting consequence is that the purely feed-forward system disintegrate. It's not a system according to this theory, so that in fact if you take even a very complicated feed-forward system, there is nothing it is like to be that. You can show this because recursively nothing can act back on itself, and therefore there is nothing there. We can use it, but it doesn't feel like anything. And a key consequence of that is that you can build two systems, one on the left which is recurrent and one on the right which is the equivalent, purely feed-forward version of that recurrent system, which have exactly the same input-output function here up to a t equal 4. So they do exactly the same job. You could treat them, they behave equivalently for any question and answers you want to get from them. And yet, if you do the analysis according to IIT, the one on the left feels like something, is something, exists. The one on the right, we can use it, but it doesn't exist at all in and of itself. So there is functional equivalence without conscious equivalence. Let's leave this out because it's too complicated. Let me just show you some predictions of the theory. So these are very rough predictions. If consciousness has to do with integrated information, and we can't, of course, measure it properly in a real brain, well, let's do something rough. Let's go for something that sort of captures the idea of integrated information in those cases in which we know that consciousness changes in a radical manner. And these include sleep, include anesthesia, include brain disorders of various kinds. So we used, together with Marcello Massimini, transcranial magnetic stimulation, which is a way to induce a current in a particular part of your cerebral cortex, and high-density EEG to record the responses of the brain. And we did this in subjects when they were awake and they were, for instance, in deep sleep, the time which, if I wake you up, you have nothing to say. So in that case, if I show you now the currents generated by the brain when I perturb a particular region, doesn't matter which one, when you are awake, you see that there is a strong local response under the coil when you stimulate, and then it moves around. These are the peaks of activity all over the place for roughly a third of a second. So you can see this is a complicated pattern of activity where an electrician going in, stimulating the brain, responds in a complicated manner. And it does so, as I said, for roughly 300 milliseconds or so. That's typical when you are awake and conscious. Now we take the same person, say exactly the same spot, exactly the same intensity, when the person now has been 40 minutes into deep sleep and he is not conscious at all. And what we get now is that the local activation is just as strong, if not stronger. The brain is active and it is reactive, we know that. But curiously enough, now the activation doesn't go anywhere else. It remains localized, as if the system has disintegrated into local domains, and you can do it in different places. You activate that place, but it doesn't go anywhere. Somehow, even if neurons are there and the neurons are active and reactive, it doesn't integrate well. This is what happens qualitatively. We see a sort of snapshot of all this complicated activity superimposed in time in wake. In deep slow wave sleep, you lose integration, you break into pieces, and in REM sleep, when you dream, it comes back, so it doesn't matter whether you are awake or asleep. And finally, we can actually try to quantify this, so it's not just qualitative, and we use here Lempel-Ziv complexity. Assuming the system is integrated, then how differentiated it is, sort of how compressible the pattern of activity is, should be a rough indication of information integration. We binarize the currents after source density analysis. This is the spatiotemporal matrix, the places in the brain and time. We try to compress it, so we zip with TMS and we zap, with Lempel-Ziv. And what you get is that in wake, you have a matrix which is hard to compress. In sleep, you have a matrix which is easy to compress, and you may even get a big response, like at the bottom, if you give a very big pulse, but it's homogeneous, and so it's easy to compress again. So it fits with the notion of integrated information. This PCI is a perturbational complexity index, is basically inspired by phi without being phi. And this is a recent study in which, in collaboration with the group in Liège and with Marcello Massimini, we showed that these are all individual subjects. This value of this rough integrated information proxy in the brain measured with TMS-EEG is high in every subject, every individual subject when they are conscious. Then when they go into deep sleep, or these are three different anesthetics, midazolam, xenon, propofol, all different mechanisms of actions. Every time you lose consciousness, it drops down to 0.2, 0.23 or so. So systematically, each individual subject does as it should be. These are brain damage patients of the sort that Christof showed you. At the very bottom are vegetative patients who are unconscious. The index is always very low. Then on the right, at the very top right, there are patients who are locked in, who have no behavior, but we know they are conscious. In that case, it's as high as in you and me. And in between, there are these complicated cases, minimally conscious patients, sometimes behavior you can't tell. The index gives you something that suggests whether they are there or they are not there. You don't need to communicate with them. This is based on a theory. It works in each individual subject in many different conditions, and so far they had nothing like that that can sort of tell us, based on a theory, whether you might be there or not. So I'll leave it to Christof to finish.